If you've ever driven on an Australian road, you probably know the sight. That tragic and just all too common glimpse of a kangaroo killed by a car. It feels like a completely random, unavoidable accident. But what if it's not? What if there's a pattern, a hidden set of rules that could help us solve this deadly mystery?
First, let's just try to get our heads around the scale of this problem. Every single year, it's estimated that a staggering 9 million kangaroos and wallabies are killed on Australian roads. I mean, that is a massive, massive number. And it's a huge cost, not just in animal lives, but in vehicle damage and, sadly, human injury and distress too.
So it really begs the question, is it just bad luck? Or is there something specific going on? Something about the time, the place, or the environment that leads to these collisions? Well, that's exactly what we're going to investigate by digging into the science. Okay, so let's dive right in. Our story takes us to a semi-rural area in New South Wales. Here, a group of scientists basically became detectives. They focused on a couple of short stretches of road that had become known as a local hotspot for kangaroo collisions. Their mission was simple: figure out why it was happening right there. And what exactly is a hotspot? Well, it's just a specific location where these incidents are happening way more often than you'd expect. And that simple fact tells us something huge. These events are not random. Something about these particular places is drawing kangaroos and cars onto a deadly collision course. So to crack the case, our scientific detectives gathered every single clue they could find. They recorded the time of day, the season, the weather for every incident. They even looked up at the night sky, noting the phase of the moon. And back on the ground, they measured everything: fences, roadside vegetation, speed limits, and crucially, the distance to the nearest streetlight.
With all that evidence gathered, the pattern started to jump out. And the first major clue didn't come from the road itself, but actually from the calendar.
This chart is really telling. A whopping 48%, that's nearly half of all kangaroo road deaths happen during winter. And the likely reason for that? Well, less rain and colder temperatures mean there's less food around, and that forces kangaroos to travel a lot farther, crossing more roads more often just to find something to eat. So the seasonal pattern, that makes a lot of sense. But the next piece of evidence was something, well, a lot less obvious. A clue that was hiding in plain sight millions of miles away.
Okay, this is where it gets really fascinating. It's not just about a full moon or a new moon. The data showed incredible specificity. Almost half of all the collisions happened during one very specific phase, the waning gibbous. For those of us who aren't astronomers, that's the period of bright moonlight right after a full moon. This strongly suggests that the amount of ambient light plays a huge role in how active kangaroos are and when they choose to move.
The moon was a really interesting lead, for sure. But the most critical clue, the prime suspect in this whole investigation, wasn't up in the sky. It was right there in the interplay of light and dark on the side of the road.
And this right here illustrates this central puzzle of the whole study. Get this. On the one hand, 95% of the incidents happened in the dark, on unlit sections of road. But then, on the other hand, 3/4 of those happened very close to a lit section. So the danger zone wasn't the light, and it wasn't the dark. It was the edge between them.
So why that edge? Well, you've got to think like a kangaroo. As a prey species, their instinct is to avoid bright open areas where predators can easily spot them. The researchers figured that streetlights create these kinds of barriers of light, which effectively funnels the kangaroos to cross the road at the very first patch of darkness they can find. So here's the crucial point. It's a two-part trap. The kangaroo is being funneled into crossing at a specific dark spot. But at the exact same time, the driver is leaving a brightly lit area and plunging into darkness. And it takes our eyes way longer to adjust from light to dark than the other way around. In those critical seconds of adjustment, a dark-furred kangaroo on an unlit road is almost impossible to see until it's too late.
Okay, let's see how this all comes together, because this is where all that detective work really pays off. When you understand exactly where and why these collisions happen, you can start to engineer some really intelligent solutions.
The science points directly to the answers. Instead of that patchy lighting, we could create more uniform light to get rid of those dangerous dark funnels. Or we could install temporary signs that only flash during those high-risk moon phases, like the waning gibbous.
There are even virtual fences that use light and sound triggered by headlights to warn kangaroos away from the road. And of course, there are wildlife underpasses, which give them a completely safe way to cross.
So, a tragic accident that seems completely random is actually a predictable event dictated by food, moonlight, and the biology of both kangaroos and humans. This case is pretty much closed, but it leaves us with a really crucial question. How many other conflicts between our world and the natural world are just waiting for a scientific detective to uncover the clues? What other hidden patterns could we find if we just knew where and how to look?